Hello, let's look at more examples of using function notation. So here's a situation where an algebra book is dropped from the Sears Tower, and this function gives you the height. So we've got an extra thing before. Previously, we would have looked at this just like h equals 1454 minus t squared. And you would plug in values of t, the number of seconds, and get a corresponding value of h. But this time we're throwing in this other thing. But remember, f of t stands for exactly the same thing as h. But this kind of notation lets you specify what the input is. Now again, some things to remember about this is you read this as f of t, not as ft or f times t or anything, because it's important to remember that this right here is not multiplication. You're not doing f times t. F isn't even a number. F is just like a name for the function. So the variables are h and t here. H is the output variable, t is the input variable. And the formula for the function is this stuff over here, the 1454 minus t squared. So anyways, I want to talk about the difference between evaluating a function and solving an equation. So to evaluate a function here means take your particular values of the input variable and just plug them in. So for example, f of 0 here is what we're going to plug in here because we're using t equals 0. So f of 0 is the result of replacing the t with 0. So this should be 1454 minus 0 squared. And 0 squared is 0, so this just gives you 1454. Likewise, f of 1 is going to be what you get when you plug in t equals 1 into the formula. And f of 2 is the result that you get when you plug 2 into the formula. Let's see how to calculate this really quickly with your calculator. So you could make a table using the y equals the thing, and that's fine. Or you could just type out the expression with a particular number, like we need to plug in 1, so we're going to do 1454 minus 1 squared. You get that result. Then the way you can speed this up a little bit is you can hit second entry and just go back to the 1 here and overwrite it with a 2. Second entry, go back and make that be a 3, and then that gives you these values for the table. And we can just go ahead and plug those in. So taking those values that are the outputs and plugging the inputs in to get the outputs, that's called evaluating a function. Now solving an equation is a different thing. Here we don't know what the input is. It's given that the output is 1390, but we don't know what t makes this work. So it's the same thing as solving equations before, finding the value of a variable that makes this equation true. So the trick is that f of t here, really, you could think of it as just the same thing as the result from this. So I could just write that 1454 minus t squared, that is f of t. So I'm just making a substitution, replacing the name of the function with its formula. And that's what we want to make equal to 1390. So we've got a quadratic equation to solve. You can, let's see, subtract the 1390 from both sides, which gives you 64 minus t squared equals 0. You could actually solve this equation with just about every one of the methods. A quadratic formula would work, but I think the easiest way to do this is by factoring, because 64 minus t squared can be turned into 8 plus t times 8 minus t equals 0, and that either gives you t is negative 8 for the first one, or t equals positive 8 for the second one. Those should both work. And yeah, those are two values of t that make 1454 minus t squared, also known as f of t, equal to 1390. And we can check it like so. Plug in that for t and make sure that we get 1390. The formula says that f of 8 should be 1454 minus 8 squared, so that will become 1390 after you do 1454 minus 64. Okay, so we got that, and the same thing's going to happen with negative 8, because negative 8 squared is still positive 64, and that also gives you 1390. So it sounds like we got an answer here to that. These are values of t that make the output 1390. Now here's a couple exercises for you to do to practice what you hopefully just learned from function notation. These are definitely good practices, good things to practice, because we are going to be using this kind of function notation for all kinds of different functions in the rest of the class. So it is an important foundation for the future. So definitely practice it now, and you can check your answers in the book if you need to, but make sure to give credit if you just copy them. And hopefully I'll see you in class and we can do some more activities to practice these concepts.